All right, let's try some of the homework for section 33.2, graphing polynomial functions. For the function, find the maximum number of real zeros, max x-intercepts, and turning points. Okay, highest degree is 7, therefore there's 7 real zeros. Oops, 7 real zeros. There's maximum of 7 x-intercepts, and turning points, there's always one less, 6. Oh, same question. Highest degree is a 7, so 7 zeros, 7 x-intercepts, and it may have 6 turning points, a maximum. For this function, use the leading turn test and the knowledge of y-intercepts to match the function. Okay, so it's an x squared, and it's positive. So that'll be a high-to-high graph, like this, and the y-intercept will be -2. So it has to look like this and have a y-intercept of 2. Upside down, no. Ooh, maybe. No, has to be this one, because it has to be a high to high. And there's the y-intercept as -2. That's the one right there. Sketch the graph of this polynomial. It's a cubic, negative, so it has to start high, end low. Oh, I don't know about that. It's not showing us, those aren't showing us the whole graph. Can't be that one. I'm leaning toward this. The y-intercept is 0, because there's no term there, so it'd be 0. That has a y-intercept of 0. So does this one. So does that one. I guess a little bit bothersome because I don't know exactly where this graph might go. Like it might go like that, or this one might go like that, or like that. So I'm not exactly sure. I could plug in some other numbers, or why don't I factor in? Let's factor out a negative x squared. That'll leave me with x plus 5. So there should be a y-intercept. It actually should bounce at 0 because there'd be if it's x squared, that would give me 2 zeros of 0, and it'd give me one of -5. So it should bounce at 0 and go through at -5. -5 is about there, and it does bounce there. Has to be that one right there. Sketch this graph. Okay, so the zeros that I have, let me write it out again up here. So x minus 3, x plus 5, x minus 7. So from here I get x equals 0. Here x equals 3, x equals -5, x is equal to 7. And there's 4 factors, and it's positive, so it has to be a W graph like that. High to high, with a couple bumps in the middle. So, boy, I can't really tell that one. Oh, I don't know if I drew that right. That looks upside down. I'm not going with that one. That's a W graph. That's an M graph. That's a cubic graph. Has to be this one. Let's just check to see if it crosses where we think. So -5, yeah, maybe. 0, yeah. 3, yeah. 7, yeah, has to be that one. Oh, another one. Sketch this graph. So it's negative, and it's even, so it has to start low, have some bumps, and then come back down. Something like that shape. Not a cubic shape, not a cubic shape. And it has to be upside down, so it's not that one. It has to be this one. I could go through and figure out some x-intercepts, but I think based on the shape, it has to be that one. Another one, right on. So it's negative, and there's 1, 2, 3, 4. So it's quartic, so it's an x to the 4th graph, and it's negative, so it's going to start low and end low. So it's an M graph, not that one, not that one. Oh, but which of these is it? Oh, I think on my labs, you can zoom in on these. And the thing that you'd want to zoom in, and I can't really tell from here, what's very difficult, is look at the zeros. So the 0 from that one would be -2. From this one would be 2, and there's 2 of them, multiplicity of 2, so there has to be some bouncing there. And then this one would be x equals minus 1. So I need to cross at minus 2. Maybe I'll draw my own. So cross at minus 2, cross at minus 2, cross at minus 1, and at positive 2, do a bounce. And it has to look like an M. So the graph would go like this, up, down, come back up, and bounce and go back down. So if you can zoom into these two, one of those I'm thinking might look like that. Now, it's bouncing at positive 2. This one looks like at 2, there's a bounce. This one looks like it crosses there. I'd probably be picking that one, but I can't really tell because I can't zoom in. Oh, another one. X, now it's an even because there's 2 plus 4, so this would be an x to the 6th graph. It's positive, so it's positive even, so that means it starts high, does some stuff, and ends high. Okay, so not that one, maybe, not that one, maybe. Now, at x equals negative 2, because that's 2, it has to have a bounce there, or tangent, and at x is equal to a positive 1, it also has to have a bounce. So take a look at these two, and which one bounces at minus 2 and a positive 1? This one looks like it does. No, that one's bouncing at negative 1 and positive 2. No, not that one. Has to be this one. Another graph one. Okay, graph this polynomial and choose the correct graph. Oh, this could be tough. I don't know if I could factor that. Oh, maybe I could. I guess I could try. One thing I can do though is I can narrow things down. So it's a cubic graph and it's positive. So it has to start low, end high. Not that one, not that one, not that one. Oh no, it could be that one. Whoops. Could be that one and that one. So C and D are in the running. So I just need to find the zeros for them. Another thing I could do is like here, this one looks like it goes right through at 0. And here, I can't take an X factor out of all of those. So I'm suspect that that one's not it. I'm probably going with D. But let's do a bit of work and just see if we can confirm any of the other zeros that they have there. So the only tool I have to try and factor something like this would be group factoring. So let's try it. 12x cubed minus 9x squared minus 108x plus 82. Okay, so out of these two, I think I can factor 3x squared, leaving me with 4x minus 3. Out of these two, oh, that's an 81. What am I doing? You probably noticed that, but I didn't notice it. 81. Okay, I think that I can factor 27 out of that. So if I factor out a negative 27, I think that gives me a 4x minus 3. Nice. Lucky. Okay, so this is f of x is equal to that. So f of x is equal to 4x minus 3 is common, and then I have 3x squared minus 27. Let's continue over here. So I have 4x minus 3 equals 0, or 3x squared minus 27 is equal to 0. Add 3 to both sides, divide both sides by 4, I get 3/4. So is there a x-intercept of 3/4? I don't think on this one. 3/4 would be over there somewhere. This one has that. D's looking good. Okay, let's finish this one. So add 27 to both sides, divide both sides by 3. Ooh, square root principle, plus or minus 3. So I have to have a 0 at 3/4 and at plus or minus 3. There's minus 3. There's plus 3. Yes, D is the correct one. Okay, last question. Using the intermediate value theorem, determine whether there's a 0 in between minus 3 and minus 2. So what I need to do is I need to figure out what is f of minus 3 and what is f of minus 2. And if the signs that I get out in the end here are different, then there is a 0, at least one 0 in between them. Okay, so let's do minus 3. So 4 times minus 3 squared minus 3 times minus 3 minus 6. Minus 3 squared is 9 times 4 would be 36. Minus 3 times minus 3 is a positive 9 minus 6. So 36 plus 9, 45. Minus 6 is 39. So it's positive 39. Let's see what happens with our minus 2. Minus 2 squared minus 3 times minus 2 minus 6. Minus 2 squared is 4 times 4 is 16. Minus 3 times minus 2 is a positive 6 minus 6. So 16 plus 6 is 22 minus 6, 16. Positive though. So they're both positive, and so that tells me that I can't tell whether there's a 0 in between them or not, because they're both positive. There could be a 0, there could be 2, there could be more zeros than that, but because they're both positive, I can't definitively say that there is a 0 in between them. So, which of the answers is right? By the intermediate, the function does not have at least one real 0 between A and B. Does not have. Well, I can't really tell, because f of the first number is 39, and f of the second number is positive 16, but I can't tell that. I don't know about that one. By the intermediate, the function has at least one. No, because one's positive, and the other one's also positive. So because they're not opposite signs, I can't say it. So it's this one. I can't tell. The only good thing with the intermediate value theorem is if one was a positive and one's a negative, then you can definitively say in between those, or those two numbers that you plugged in, say they're there and there, the graph crosses. But if they're both positive or both negative, you can't tell that. All right, hopefully that helps you with the homework for this section.